delta G, sign of change in Gibbs free energy, which is delta G, indicate the direction of a chemical reaction and then determine if a reaction is spontaneous or not. So here we are saying that entropy alone is not enough to tell us if a reaction will be spontaneous or non-spontaneous, but with delta G, Gibbs free energy, is actually the one that can determine if a reaction will be spontaneous or not. Now let's take a look at this. If delta G is less than 0, if delta G is less than 0, that means delta G is negative. And I told you whenever delta G is negative, the reaction is spontaneous. Reaction will be spontaneous, that is hexagonic. That means that reaction is hexagonic. A spontaneous reaction is hexagonic, and that means that the reaction is giving out heat. The enthalpy there will be exothermic, is negative, hexagonic. Then when you have delta G equals to 0, if delta G is not negative nor positive, it is equal to 0, then that means that reaction is at equilibrium. That reaction is at equilibrium. So there will be no net change, either in forward or backward reaction. But when delta G is greater than 0, that means delta G is positive, then the reaction will be non-spontaneous, and that shows endogonic. That means enthalpy there is endothermic, it's absorbing energy, so it's hexagonic. Then the reaction will be non-spontaneous. So we have to take note here that delta G depends only on the difference in free energy of product and reactant, that is the final and initial state. Delta G is independent of the path of the transformation and is often affected by the mechanism of the reaction. The way the product is being formed, the route and everything is of not a concern to Gibbs free energy. What Gibbs free energy is all about is the difference between the final state and the initial state, just the reactant and the final product being formed. How the product is being formed is none of its business. So delta G cannot tell us anything about the rate of reaction. We are still going to rate of reaction so we understand this very well. So delta G cannot tell us anything about rate of reaction. Now the standard state free energy of reaction, delta G, is defined as free energy of reactant as standard state condition. So you can see this is the equation here. So whenever enthalpy change is less than the product of temperature and change in enthalpy, then the reaction is enthalpy driven. In this case now, the enthalpy is greater than the product of temperature and entropy. So that means the reaction is enthalpy driven. But if enthalpy is less than the product of temperature and change in entropy, then the reaction is entropy driven. So we've mentioned this formula. We should just read through this place, just talking about the standard free state of energy formation. Now this is another example here, just like the one we have before. Here we want to calculate the change in Gibbs free energy for the following reaction at 25 degrees. Then they want you to now state if the reaction will occur spontaneously or not. So you are given this equation. So from the equation, your enthalpy change is minus 176, and then your entropy change is minus 284.8 joule per Kelvin. Remember, once it is in joule, your entropy, you have to convert it to kilojoule. So doing that, Okay, so when we put this back into the formula, delta G equals to delta H minus this. So when you convert your entropy, you have into kilojoule, we have minus 0.284.8. So put everything back into the formula, then your final answer will be delta G equals minus 91.1 kilojoule. So in this place, delta G is negative. And you know, once your delta G is negative, then it means the reaction is spontaneous. So we can now conclude that the reaction is spontaneous at room temperature since delta G is negative. So finally, or in conclusion, just say in conclusion, I want you to note this, that your Gibbs free energy is the energy associated with a chemical reaction that can be used to do work. The free energy of a system is the sum of its enthalpy plus the product of the temperature in Kelvin and the entropy change of the system. That is, your free energy will give you your the sum of the product of your entropy and then your enthalpy and the temperature. Okay, then your free energy of reaction, in that case, that is where you have your change in G to be equals to your change in enthalpy minus temperature multiplied by change in entropy. So that is what we still have here. So you take note of this formula. Then another thing you need to take note here is reaction can be classified according to the change in free energy of the reaction. That is, we can use free energy to know if a reaction will be spontaneous. I told you if a reaction is spontaneous, that means the reaction is hexagonic. But if the reaction is non-spontaneous, then the reaction is endergonic. So for endergonic reaction here, that is for non-spontaneous, your G will be greater than 0. That means Gibbs free energy will be positive. Then it is non-spontaneous. But if Gibbs free energy is less than 0, then that means it is negative, and then it will be spontaneous. So that is what we still have here. But when Gibbs free energy equals to 0, then you should know it is in equilibrium. Then if a reaction is favorable for both enthalpy and entropy, I told you it is now then the reaction will be spontaneous. That is, if enthalpy is negative and then entropy is positive, then our G will definitely be negative, and then that will make the reaction to be spontaneous. Negative enthalpy, positive entropy will give you negative Gibbs free energy, and hence a spontaneous reaction. If a reaction is unfavorable for both enthalpy, that is, enthalpy is positive and entropy is negative, then the reaction will be non-spontaneous because Gibbs free energy will be positive, will be greater than 0. So if a reaction is favorable for only one of either entropy or enthalpy, then it is the standard free energy, Gibbs free energy, that will now determine if the reaction will be spontaneous or not. So go through the reaction very well, the examples, the calculations, study them. This topic is very, very important. So if there's any aspect that you don't understand, as usual, try to contact me. Thank you. Stay safe.